Yeah, but they never answered that. Is that true?
I don't know enough about the Well, I know about the pre-gorgeous stamp. I don't know. All right, we're going to go ahead and get started.
Might know about it.
Hey, this is great, you know. So I'm going to introduce Valene Cauhorn. Cauhorn, sorry. Utah versus Idaho accent, I guess. I don't know. So we'll just go from there. So Valene is an Idaho native and serves as the Idaho manager and agricultural engineer at Ag Professionals. She's a licensed professional engineer in Idaho, Washington, Wyoming, Utah, Iowa, Colorado, Ohio, Kentucky, New York, and Pennsylvania. Valene specializes in agricultural engineering, including the design of feedlots, dairies, associated drainages, and confined animal feeding operations compliance. Beyond the agricultural sector, she also engages in civil design for commercial development projects and manages large agricultural and commercial jobs. Raised on a generational farm and beef cattle operation in southern Idaho, Valene now lives with her husband on their farm and cow-calf ranching operation in the same region. She graduated from Colorado State University with a degree in civil engineering, concentrating in soil and water, and with an additional emphasis in animal service. Valene is a board member of the Idaho Cattle Association, representing District 3. She's also the co-host on the Millennial Ag podcast. Please welcome Valene.
Well, thank you very much for having me, and thank you for that kind introduction. I'm honored to be invited down to Utah. It wasn't that far of a drive, and I'm happy to join you all today. I'm going to dive into kind of bridging the gap between ag and engineering. So I appreciated John's previous presentation on painting a little bit of the picture of where that can happen, specifically in the water rights sector. So I'll touch briefly on some of the water rights. And as he was talking about the project and mentioned Delta, Utah, my co-host on the podcast is originally from Delta, Utah, and her family still resides down there. So small world. I'm not going to dive into this too much. Did a great introduction, and I appreciate, again, being here today. A little bit of a roadmap of where we're going to go and what we'll talk about. I'm going to start painting the picture on why agriculture is important, and then what ag engineering is, and then I'm going to talk about the areas that I focus in primarily, which is your confined animal feeding operations, little bit on irrigation, and then where we're seeing some urban-rural interfaces happening as well. So why is ag important? I want to first start off by saying it's because we all need to eat. Agriculture feeds the United States and the world, and so it's a good base for the economy as well. To paint some of the economic drivers here, cattle inventory. So this includes beef and dairy, and it includes all from the babies all the way to milking cows or cow-calf steers, that sort of realm. The U.S. has about 86.7 million head of cattle and calves, which is the lowest since 1951. And there's lots of data on this, but we're seeing this due to drought and due to older generations not staying in production. Based on 2024, there's approximately 1.88 million farms in the U.S. Again, this is the lowest number in over a century. This is due, again, to consolidation and the amount of the older generation not coming back and the rural-urban interface and development of agricultural lands. The economic impact, it's about $1.5 trillion to the U.S. GDP. This was back in 2023, which represents about 5.5% of the total economy for the United States. Exports is a huge benefit in our ag. About 176 billion goes to Mexico, Canada, and China, which is about half of our exports. There's a lot of exports going down to South America and other, the EU has a little bit, and then the Korea, Vietnam, Japan, that area also has a lot of US exports onto it. Want to drive home also that 95% of the US farms today are still family owned and operated. There's a lot of different sizes and scales, but they're still family owned and operated. And then the latest statistic I could find back in 2022, ag, food, and related industries provide about 10% of the US employment, with direct on-farm employment accounting for only 1.2% of the total US employment. So the number of people on farms and ranches, again, is all-time low as well. So what does this have to do with engineering? There's a variety of different areas it plays, and it's a very broad scope. I'm going to go through each of the areas, and then we'll dive into some target areas that I focus in. Equipment design and innovation. This is more on the mechanical, electrical side of things. So development of machineries like tractors, irrigation systems, pumps, generators, and then drones are becoming more and more popular all the time. They're now using drones to fertilize, they're using it to spray crops, they're using it to target specific areas, and you can program it in on saying, hey, I need you to go map out these certain weeds in this potato field, and they can just go start and it'll map it and just zap them. So it makes it really efficient. It's still very expensive and not done a whole lot, but it's becoming a huge industry. Precision ag, I just mentioned the drones and targeting specific areas. So using the GPS sensors and data modeling, they'll do, for farming specifically, they'll take grid samples and find where those fields are testing, you know, high in nitrogen or phosphorus, and then low in nitrogen and phosphorus. And so they can optimize how much nutrients are getting placed on the field to optimize crop growth while saving cost as well. So a lot of fun opportunities, but they also can do that with water and pivots nowadays too. So it's, again, I don't camp out a lot in this, but I am exposed to it. And so mechanical, electrical play a huge role in these developments. The infrastructure and systems, this is where I kind of camp out in on my day-to-day, designing barn grain storage, confined animal feeding operations is where I'll dive into, irrigation networks, more of the structural and civil side of it. I'm not going to spend too much more time, as we'll dive into that. Sustainability and environmental impact. I'll spend some time on this with manure management, and making sure that we're conserving water, minimizing emissions, and taking care of the planet in the process. And then automation and robotics. This is, again, growing rapidly. I've seen, specifically in the dairy industry, a lot of robotics be introduced to the point where they still need employees, but the cows can go into what they call a box stall and milk themselves on a day-to-day basis. There's automatic feed pushers and sensors, AI technology that's ever evolving. They're using the same kind of technology to harvest crops. Again, it's very, very expensive and not seen, I would say, on a large scale quite yet, but this is growing and changing every day. A lot of the tractors, I'll drive by the fields and the guys are on their phone or reading a book or doing whatever, because the tractor is pretty much driving itself with all the GPS equipment. So it's pretty remarkable how far we've come just in the last 10 years on this technology. So I went ahead and pulled the American Society of Agricultural and Biological Engineering definition. So that is the application of engineering principles to agriculture, including the design and improvement of farming equipment and machinery, soil management, water resource, irrigation drainage, crop production, and livestock facilities. So again, very, very broad area, just like any, just like civil engineering, you can dive into 10 different fields with that. Ag engineering is very much the same way. So the target areas I'm going to discuss today are your confined animal feeding operations. Some places you'll see concentrated CAFOs. Some people call them CAFOs. Depends what side of the border you're on of Idaho or Utah. But I call them CAFOs, not offended by CAFOs. And then we'll go through the kind of the permitting process, design and engineering, and then the nutrient management planning of that as well. And then I'll touch briefly on other ag support, irrigation infrastructure, some other structural engineering we do, and then finish up talking about the integration at the urban-rural interface. So confined animal feeding operations, CAFOs. The EPA, from an environmental standpoint, CAFO regulations fall under EPA. So I went ahead and pulled the definition. An animal feeding operation operations are agricultural operations where animals are kept and raised in confined situations. An AFO is a lot or facility other than aquatic, so this does not count fish. That falls into a whole nother area, where the following conditions are met. Animals have been, are, or will be stabled or confined and fed or maintained for a total of 45 days or more in a 12-month period. And crops, vegetation, forage growth, or post-harvest residue are not sustained in the normal growing season over any portion of the lot or facility. So pastures where cattle are grazing out there or chickens are free range, that does not fall under the definition of an AFO. So AFO is usually anything under 1,000 animal units, and then they'll trigger it to a large CAFO, which is above 1,000 animal units. Standard, and this changes from state to state as EPA has delegated their regulatory oversight to the state entities, is typically about 1,000 animal units, and usually 1,000 pounds equals 1 animal unit. So if you're milking those big Holstein cows you see, they're usually about 1,400 pounds. About 700 of those is considered a CAFO. And again, states have different regulations, and so do the counties, which I'll dive into in the next slide. But engineering opportunities for CAFOs is ever growing, including land planning and permitting, water rights, grading and drainage, structural, and then manure management on the backside. So land planning and permitting, similar to any project you all may work on, commercial, industrial, or residential. Most projects require permitting with the local jurisdiction, either the counties or the cities. Most of the time we're working in the counties because CAFOs should be sited away from the urban population, but there is some overlap depending on where you're at in the country. And usually a special use permit is required along with public hearings and so forth to be transparent to the community on the project that's happening. Each new CAFO or expanding CAFO must carefully plan out their projects to mitigate any impacts they may have on neighbors or any neighboring properties that could be affected. And I would say, in my experience, most counties have stricter number requirements than EPA does. So even like a 200 head feed yard in rural Idaho will have a county permit for that. So they're the ones that want to make sure that they're protecting the neighbors and the resources available. The resources we look at before even starting or expanding a project, does it have enough water? What's the traffic impact? And then making sure there's a plan for the runoff, ponds, that sort of thing. And then on-site septic and so forth has to be permitted as well. Typically, CAFOs are only allowed in agricultural zones. Very rarely will you see them in residential. It would be shocked if I ever saw one there. Commercial, some counties may consider it a commercial use and might let them in there, but most of the time they like to see them out in the agricultural zone away from everybody. And then EPA, I touched on this on the previous slide, has delegated down to the states to enforce the Clean Water Act on CAFOs, and each state manages their regulations. So they want to see that run-on and runoff calculations have been completed, and water that comes in contact with manure stays on site and is planned for. Protecting groundwater, ensuring that the ponds are lined with a certified liner and meet typically it's 1 × 10⁻⁶ centimeters per second seepage rate. Each state, I've seen it go to -7 and -8 in some stricter states as well. And then ultimately protecting surface water as well, making sure that manure stays on site and doesn't run off into any neighboring surface water. Water management, similar to the last presentation, water management is huge. And when you're dealing with stakeholders and limited water supply, water management is, I would say, a huge priority, especially in Idaho and Utah, where water is scarce and limited. Water rights are done through the prior appropriation, first in time, first in right. And so making sure that new uses, a new facility, for example, has gone through the process of transferring those water rights and has the available water to feed those cows, and making sure that those water rights are fairly senior too, because it would not be a good thing if there was a call and the cows couldn't get the water. So making sure that that's well planned out. There's a lot of technology in the recycle and reuse of water on most confined animal feeding operations, whether it's beef, dairy, poultry, or hogs. A lot of feed yards, if they're in the winter, they'll overflow the water troughs to keep water movement so that they don't have to thaw out the water tank. They'll recycle that, treat that water and recycle it back to be reused. The dairies reuse the water 3, sometimes 4 times before it ever makes it to the lagoon. So being very, very mindful of water is really important, especially in the Western United States. When we get into the Eastern United States and coastal regions, I have done a project in Hawaii. This is a whole different animal because you're dealing with like hundreds of inches of rain out there. And so making sure that we account for too little water or too much water, and balancing that out is important. So a big thing is, where's the water coming from and where is it going? I see a hand in the back of the room, and I think I'm going to ask you to fill in the app, please. So I'm following procedure. But making sure that where the water is coming from and where is it going is really, really important in the first stages of the project. The next area is grading and drainage. Civil engineering and design of livestock production facilities and operations has become more and more common than it ever used to be in the past. A lot of the old cattle feed yards, I would say primarily, and even the dairies, would expand or add on as it was convenient. So back when cattle were being domesticated, they'd round up 20 wild cows. And this is like still happening in some of the Texas, Arizona areas. But they'd wrangle up the wild cows, put them in a corral, and go, okay, I need a pen for 20. Well, then next day, they'd get another 20, and they'd expand. And they'd just keep on expanding based off of what was needed at the time. With transportation, the price of cattle, it is more important ever, and protecting our environment, it's more important than ever to make sure that we're adding those engineering components into it and being strategic about where we, place these cattle, chickens, hogs, and how we're operating. So we now do full-on grading and drainage plans, similar to what you would see in a municipal project. There's definitely different considerations with that, which I will talk about on this slide. So the key one is proper drainage and we want to keep the cleanest facility we possibly can. Um, the things we consider when we lay out a facility are going to be your traffic flow. So where are your commodity trucks coming in? Where's the feed stored? And do you have good access point from there? So less overlap with traffic, just like you would consider any other, where your employees coming in versus where your delivery trucks coming in, is really key. And then inside, how are the animals flowing? What's the shortest path to get to the milk parlor? What's the shortest path to get to the cattle handling facility? And what's the best way for employees to move cattle efficiently? Locating your commodity and feed storage. So feed prices fluctuate very dramatically, but it's huge input cost for these operations. So how can we efficiently store our feed for the facilities by keeping it dry, by reducing the amount of wind that comes in contact? Shrinkage for some of the facilities is really huge, which is a loss of feed. So how do we design buildings and location where we can control feed? And then the most important is the animal comfort, making sure the cows are well cared for and they have good dry footing in these facilities. The next one is structural. So similar to, I would, grading and drainage, structural has become more and more prevalent and important. CAFOs are moving to indoor housing and climate control. You see this a lot in the poultry and hog industry. Most of those facilities are now enclosed, and dairy's starting to enclose their cows in large cross-vent barns. And I tell people it's sunny, 65 degrees, 365 days a year. And you walk in and it's like you're on the beach. There's a nice breeze and the cows are happy. And so a lot of guys are starting to look at those opportunities and bring those animals inside. So a lot of structural engineering, a lot of times they're large steel structures, just like you would see in a warehouse. But we help lay out so that the cow traffic doesn't run into a column. So we still have to lay out columns and footings and foundations to meet the internal side of it. And then we also have to consider management, because a lot of times the floors of those buildings are concrete. And so where is the manure going to go? Because the cows are still producing manure every day. And so how do we keep those facilities clean on a day-to-day basis and handle that manure as well? Other areas for structural commodity storage, like I talked about, again, a large steel structure. There's a guy out in Mountain Home that's got a flyover commodity barn where the truck drives over a large bridge and dumps it down. And so the commodity delivery truck doesn't even mix with the loaders and feed trucks going to the thing. So creating bridges that large trucks can sit on, and then milk barns and office buildings as well. Milk barns, again, human flow and then cow flow as well, making sure that the milking decks are at a certain height so that employees are comfortable when they're standing and adding equipment to those cows. And then office buildings, a lot of guys are either adding them onto the dairy barns, or beef feed yards will have a nice office building at the front where employees can hang out. There's your coffee machine and your restrooms and so forth in them. So a lot of times we'll help with the building permits. Most counties, it's ag exempt. The milk barns do dabble in commercial as a product is being produced on site. So that's kind of the difference. Animals can house, but once you start producing a product, milk, it'll transition to commercial. We look at floor plan and flow. Steel building design, a lot of times we rely on the pre-engineered metal buildings and their reactions to design our footings and foundation of those. Some guys are building their own steel building, or constructing it on site. So we'll do the structural as well. Manure management. So it's very important. One of the first things I was taught early in my career was, You got to keep your clean water clean and your dirty water dirty. And so keeping them separate is very, very, very important. And I think this is, you know, applicable to all water management systems, is diverting the clean water that's could potentially run onto your site around the facility, and any water that hits roofs, that's clean water if it hasn't come in contact with manure. Once the water comes in contact with manure, it's got to be handled through the manure handling system and stored in an aligned impoundment before it's land applied to the agricultural fields at an agronomic rate. And so making sure that hydrology and hydraulics come into play, making sure our diversions are sized. Typically, the storm events are 25-year, 24-hour storm. That's kind of our standard design storm. And then making sure our lagoons are sized appropriately to hold all the winter storage. You can't land apply manure water when the ground is frozen and crops aren't growing. And so you can get fall application in, and then you can get a spring one in, but we've got to have 120, 180 days, depending on the region of the country we're in, where they can't land apply. So balancing that. If you're in Hawaii, they can apply 365 days a year, which is nice, but you have to balance the rainstorms. So it's figuring out your region and the hydrology of that area to keep that. So a lot of guys are with the larger barns now are trying to divert that clean water that's come in contact with the roofs off site so that they don't have to hold it within the ponds. The other, a lot of new and emerging technology, which fits in, I would say, with the mechanical and electrical quite a bit, is the separator systems that are coming out. And I'm going to just briefly touch on them, but it's pretty amazing that we're pretty much able to get potable water out of the backside of some of these dairies. It's not quite to scale yet, but we're at the point of having potable water that could be reused either as like clean irrigation water or back to the cows. So making sure that we're all in the loop and understand the cost, you know, the cost benefit analysis on that is also very, very important. Again, how many nutrients are there and where are they going? That's a huge part of the nutrient management plan that every confined animal feeding operation has to have. And it's a living, breathing document. It's something we create at the very beginning to make sure that they have enough farm ground, they have a plan for it, and then every year it's updated and fields are analyzed and manures analyzed, and I'll dive into that as well. So some of the manure separation and water treatment, there's the typical gravity systems, and I have guys still installing these because the power goes out and it rains, your gravity system's not going to fail. And so these are settling cells. You can see if I can figure out. The picture in the lower right hand is a feed yard I worked on. And these are actually designed, it's concrete, but the pens run off and then it slopes over to the lagoon. But these were designed to work as concrete settling cells before it got to the lagoon so that they could get a loader in and clean these out really easily without getting into their large lagoon and having to clean those out. Those large lagoons are, you know, 10 to 20 feet deep sometimes and 3-to-1 side slopes of the ponds, and it's really hard to get equipment and it's expensive to get it in. So if we can get a lot of the solids in captured before going to the pond, it makes a big difference there. So it's pretty rudimentary, but it's pretty efficient at what it does, especially on runoff and rain. So you'll see it on a lot of open lot dairies and feed yards as well. There's weir structures too that are gravity. You put 2x4s essentially, you know, and it seeps through. Some of them are weeping walls, weeps over and then flows over there. So there's a variety of different gravity methods that a lot of guys. I have some clients that'll still argue that they just want their gravity system because they know it'll work and it works every time. So it depends on how much water, that sort of thing. A lot of times these are great in low water facilities and high desert areas. So getting to the mechanical side of things, the top one is, there's actually a sloped screen in there. I should have probably pulled a picture out for you, but it's essentially runs the water over it, and then the mesh screen catches the solids, drops it out, and then the water heads to the lagoon as well. So it's a mechanical form of separation. And then the lower left is two screw presses that are, I would say, the next level of separation. And then you get to the centrifuges, which you'll see some of those in your wastewater treatment facilities as well. And those get really expensive, but those are very, very effective. And so it's, again, analyzing what your ultimate goal is with your nutrient management plan and how much money is worth spending on these kind of equipment to get to the ultimate goal of the project. So nutrient management planning, and this, there's engineering involved, but a lot of this is on the agronomy side. So we have agronomists that help us take those soil samples, manure samples, and analyze how much, based off the yield goals and the amount of, and the type of crop, how many nutrients are going to be pulled out with the crop. And so analyzing how much nitrogen, phosphorus, potassium. We also look at salts. I don't think I put salts on here, but salts, especially in the desert areas, come out of our irrigation naturally. There's a lot of salts, and so salts is a very plant limiting thing. It's not necessarily a soil problem, but the plants have a really hard time using salts at all. And so trying to reduce the salts that are in irrigation water and manure water is really important. So samples are taken from all the manure sources, and this happens annually and sometimes biannually, depending on how a facility operates. So solids, if your compost, your dried manure, slurries, whatever's going to go to the field needs a sample on it. And that includes your liquids, ponds. You can see in the bottom left-hand corner, those are some samples that I took from a facility, and we have lots of poop jokes, but I'm going to leave those for another day. And then all the farm fields that will have manure applied to them also will take soil samples from and do a nutrient balance for those facilities. And then you got to determine time of year and how much they can apply. So during a growing season, especially for cow feed, you can use the lagoon water throughout the year through the pivots. You do have to make sure it's screened really well, because they will plug pivots if you're not careful. So again, going back to how much treatment do you want on the front side to make it so application's easiest on the back side. Solid manure is usually applied fall and spring and integrated into the soil so that it takes a little time for it to become plant available. And so then by spring, it's available for crops to use, and it's a great organic fertilizer for the facility. A few of the value added opportunities that we're starting to see are the anaerobic digesters. And so you have to have enough manure for this to work. So a lot of feed yards don't do it. And I would say the poultry operations, the amount of manure on the backside is very dry and not conducive for anaerobic digesters. But dairies and hogs are primarily where you will see a lot of the digesters, and they're taking the manure and turning it to biogas. We've got one facility that converts it to electricity. They use it for heat, or they scrub it, and it's renewable natural gas that they'll inject into the renewable natural gas pipelines. So a variety of different availability for those. And it's pretty incredible how much engineering goes in on these facilities. We plug in on the manure handling side, but the amount of chemical, the amount of biological and electrical and mechanical work that gets done is remarkable. It's, to be honest, don't ask me about the bugs that make the system work, because I know the beginning and end, and what happens in between is usually left up to somebody that understands this a lot more than I do. And it's helping with carbon capture, reduces the methane emissions from the facilities as well. So pretty cool opportunities, and there's some that are up and running, and there's some that are still working out the bugs. So it's a new technology of trying to find that optimum gas production while also making it usable for the dairy as well. Water treatment. So I already kind of talked on this, but the facilities are working really hard to get to potable water. Places like Colorado, where the cities are buying agricultural water at ridiculous prices right now, are forcing guys to figure out what to do with water. And so this is water treatment's one of the opportunities for that, taking pretty much your lagoon manure water coming out of the barns, runoff, and treating it to potable water to be recycled, either through reverse osmosis, ultrafiltration, and then there's also some chemical treatments and polymers as well. So I'm not going to dive too much in. Again, I'm not a chemical engineer, and some of that is over my head when it comes to the biology side, but it's pretty remarkable that we're at a point that this is starting to become scalable. We're still figuring out the cost to run it every year, which is where the pinch point is for that. A couple other ag areas that we touch, irrigation infrastructure. I'm not going to spend too much time on this just because John did such a good job in the first presentation, but we do a lot on the, I would say, downstream side of the dams. This is a weir structure that we've worked on to divert from a canal down to a smaller ditch and then over to a pond. And so making sure that the canals and the engineering is such. A lot of times the canal companies, they'll use engineering, but they've done it for so long, they know how water works. And so making sure that we plug in where we're needed to without over-engineering it. Those guys know how their systems work, and more and more areas are starting to line canals too. In Twin Falls last year, we had 2 or 3 canal breaches. We get voles or mice or gophers, and they burrow a hole through and then burst out the whole side of the canal once the little thing. So they're starting to line canals that have really soft soils to try to protect areas. So some cool things are happening in that realm, and the canal companies and are doing a great job. Groundwater irrigation too is a big thing in parts of Idaho and Utah, pumping out of the aquifer. So wells have to be designed to pump at a rate that the pivots can use. And then you're also got to respect water rights too in this thing, which could be a whole nother presentation in itself. Some other ag support structures that we've done, a lot of foundation pads for, grain bins and silos, and then chemical and fuel tank pads. It's really important to make sure those footings and foundations are sturdy, because as you can see, those grain silos are huge. And you get a little settlement on one of them and a big load of grain, a big load of chemicals, a big load, and they'll just collapse. And so making sure that those foundation and anchor bolts are such that to support that and be a safe environment for employees to work around is big. Equipment shops and sheds, we do a little bit of work on those. A lot of times the companies know footings and foundation size and overdo it and get in and get out. Ag, they like to spend as little money as possible on engineering costs, which for little hay shed is totally fine. And then irrigation pump house and control stations, we've helped with a few of those as well, making sure that those are got enough room to move around in, and then the structure is built to standards that will allow people to be in there. Okay, the last area I'm going to kind of dive into, and this is just some food for thought more than anything. But one thing we're noticing more and more is the urban-rural interface becoming closer and closer and closer every single day. One quick example is my family farms and ranches in southern Idaho, and when my grandfather homesteaded there was nobody there. There was hardly any irrigation, and now we've got an Amazon distribution center you can see from my parents' house. So it's crazy how close this is all getting, and development is good, right? It's a sign of a strong economy. It shows that people want to be there and there's money to be shared. But we've got to do that in a very smart and thoughtful way. And so walking through a couple of these, making sure that our infrastructure can support the development. So making sure roads, bridges, and utility services are there to support the growing population. But we've also got to make sure our irrigation infrastructure is being adapted too, and making sure that it's still getting to where it needs to go, and that pivots can still have the ponds that were once where a new roadway is. So making sure that those conversations on infrastructure are happening is very important. And then protecting ag. Ag feeds the world, it feeds that growing population. So making sure we're planning for protection of ag as well. And ensuring that ag lands are preserved and supporting during urban expansion. My husband and I are farming in a lot farther than my parents are away from people, and we don't see it. We're okay for a little while, but we've also got a lot of rocks to work around. And so people don't want to live in the rocks and the desert as much, but they want to live near town in fertile soil that's beautiful with growing trees. And so balancing where can we sufficiently make agriculture viable while also providing people with opportunity to enjoy the lifestyle that I love and I love as well. So the biggest thing is making sure that we have collaborative planning. We're engaging all the stakeholders from both the urban side and the rural side to create balanced development plans, making sure that comprehensive plans are up to date, and that we have a strategic plan for where we're going to place these projects and where it makes sense. Is it near an interstate? Is it near water? Is it near other people? And then what's the traffic going to do as well? Because that's a huge thing that continues to grow and expand. And then again, optimizing our resources. Our resources are limited, so making sure that both urban and rural are getting the needs they are, but we're optimizing our water, we're optimizing our power, we're optimizing our road infrastructure as well. Is very important. And so I want to make sure people are thinking of all of it when developing projects. So to wrap it up, some things to leave you with is I want to remind everybody of the importance of ag and how it's important for food production, economic stability, environmental sustainability, and then how the role of engineering is playing into that. It's becoming more and more prevalent that engineering is needed in agriculture in a variety of different ways, as discussed today. And it's also important for the urban development to have the right engineering as well as it interacts with the rural interface. Making sure our resources are managed well, I think, is one of the top priorities, whether you're in ag or in urban development as well. And so making sure water, power, traffic is all considered, and making sure we're protecting agricultural needs as well in the process. There is my contact info, and Jason also has a copy of it. So if you want to get a hold of me, and I also plug the podcast too. So if you're not tired of listening to me, you can go check out the podcast as well. But I appreciate the opportunity, and we'll open it up for questions.
Back a long time ago when we first started settling.
We're using Slido. Please let Slido go. Just read the questions are up there.
Yeah.
In buildings that house many cows during the day, are special techniques needed to monitor and control methane buildup? Yes. Those barns are highly ventilated. The hog barns are, so I would say dairy barns and hog barns are very, very well ventilated. So hogs, the manure falls down through slatted floors and then is pumped out the side of the building. Typically in a dairy operation, it is scraped or sucked up with a vacuum truck and then pushed out the back of the barn. So yes, ventilation is important, and then manure handling throughout the barn to prevent buildup is also important. A lot of methane does happen after it's heated up, and so if you can keep the manure relatively cool, you shouldn't get too much methane buildup in those barns. Has there ever been a stampede inside an indoor CAFO? So I'm guessing you were referring to like cows going, running really fast. I've not seen one. The cows are typically used to people, but they also integrate new animals at a very slow rate, and so that you don't mess up the cattle flow, because cattle flow is very important with these facilities, so that you don't. A stampede is not very. It stresses the animal out, which also reduces production, and it's just not good for their health. So they try at all costs to prevent that from happening. Most stampedes happen when you're out on the rangeland and get a wild cow kind of stirring everybody up. In Utah, 70% of water is used by ag. 80% of that is used directly by or to grow feed crops for animal ag. Are there more efficient ag options for food out west? It's a great question, and I don't know if I have a great answer to it, but it's something that they're becoming more and more aware of. I know they're putting a lot of moisture sensors in soils to monitor how much moisture is actually being applied to those farm fields, because sandy soils need a lot more moisture than your clayey soils, just because the moisture doesn't hold within those sandy soils. So a lot of time and energy is spent on that, and then during droughts too, it's optimizing which crop we're growing. Corn requires quite a bit of water to get to final production, but your small grains, alfalfa requires a lot of water, but you can get away with 2 cuttings rather than doing the full 4 cuttings. So balancing our water, and guys are pretty dang good at it when they're required to, and they're becoming more and more efficient. Pivots are more efficient than flood irrigating was, than hand lines were, than wheel lines are. So they're getting more efficient. But then there's also the debate on recharge. So we're not flood irrigating anymore. We're being more efficient in getting the water to more fields, but that water is not infiltrating down into the aquifer. And so a lot of those debates have been had, and we're doing a lot of recharge efforts because of that turnover in irrigation practices. So it's an interesting debate that you can have on which system is most efficient, because there's a beneficial use when it comes to water. So you're given so much water to irrigate your crops with, but you're only have a beneficial use. So you convert that irrigation water to municipal, and you only get a fraction of it because there's water that's evaporated, there's water that goes back into the aquifer. That would not happen once it hits a municipal type of handling. And so I would say that while ag uses a lot of water, they're also putting water back into the system too. So it's an interesting debate we can have maybe over lunch too on water usage. What is the most unusual engineering situation you've needed to solve in this space? Oh, the job I worked on in Hawaii was very, very unique, because they got, on one side of the island, they get like 250 inches of rain a year. And so designing facilities to handle 250 inches of rain a year, and then the design storms, I want to say like 20 inches of rain or something that like out in west you just don't fathom. So it was a very interesting problem to solve. You know, you graze the cows so they're not confined. You capture whatever cow paths they have, and we even got to the point of even talking about covering lagoons with a shade structure so that you wouldn't need 200 inches just on the pond space. So you learn to get creative. Trying to think of, I would say that one's the most unique dairy I've worked on. Also done a horse race track in California, so that was also interesting. So if it touches ag, we try to do it, and if our ag guys touch commercial, then I've done it too. So it's a good breadth of that.
One more question.
Okay. Um, oh, I'll jump on the number 2 one real quick just to make it brief. I don't know much on fire suppression. Most of the barns are steel. And then new waters, are farmers able to earn income from these new sources? Yes. The digesters on site are able to provide on-farm income addition, which I would say that has helped the sustainability and longevity of the operations to provide additional income for kids to come back to the operation, because ag prices are really volatile and so forth. So yes. So thank you so much for the opportunity, and I appreciate all the questions.
All right, I want everyone to pose for a picture real quick.
Thank you very much.
Thank you. Appreciate it.
Go. And we'll take a 10-minute break. Thank you very much.
Thank you. Oh, I can probably turn this off now. You don't need to hear me breathing.
That's still good.
You're on a
Okay.
different channel.